So this video is being made to show the procedure of testing. So with this board here, first thing we need to do is lock it off. Yeah, with our safe isolation kit. Ensuring it's switched off before we put the spring in. Remembering the key needs to be in our pocket. We do not need to write on the label at this stage. So with this board, we can get our AVI, approved voltage indicator, and we check, make sure they comply to GS38. We then whack it on the proving unit to prove it works. We then do our 3-point test. 1, 2, 3. Then check it again on the proving unit. Safe isolation has now been complete. Now, the first thing we need to do is ensure that our tester is set up to the right setting with leads plugged in and set up onto continuity. We then need to null the leads or zero the leads. To do that, we hold them together like so, press the 0 setting. We then press test to confirm that it is zeroed out. It's then at this stage that we then disconnect the main earth so we can test the continuity of our main earth. We do this by clipping on to the first earth, and because this is fed from a plug, we can then do it directly onto there. We can then press test. We have a reading of 0.3 there. I'll write that down on my sheet as 0.30 ohms. Next, we reconnect that earth back in. And that is the continuity of the main earth complete. Next, we move on to bonding. This is where we find our 10mm bonding cable and disconnect it. This only requires to be disconnected at least one end. And as I hold it onto here and get the tester up into place, so the reading there of 0.04. We can then reconnect that back into the board. Next, we are going to test the lighting. In order to do that, I'm going to be using these linking out leads. Because I know I'm going to be using these leads, I can null these out at the start here. Same procedure again. Yeah, so I know them leads are now nulled out. Can then disconnect the live on that circuit. And disconnect the corresponding earth. and throw the screwdriver on the floor. I then go to my light pendant, which is the furthest point. Connect on live and earth there. Now we've got an open circuit. That's probably because the light is switched off. We'll remove that because we'll need to remove that later. We'll flick the switch. 2 point. We'll then flick another switch. Flick the final switch. Now this reading is fluctuating, but we just wait for it to balance itself. .36. So the R1, R2 for the lighting was 2.36. Next, we do our R1, Rn for that same circuit. So reconnect the earth back into the board using the screwdriver. And disconnect the corresponding neutral for that circuit. Then on the same setting, so we go onto the live and neutral terminals. And press test. Yeah, and we get roughly a similar reading. We then operate the switches. To prove polarity. Let's just get a final reading. 1.37. So for the lights, we've got a reading of 1.37 ohms. We then put all that back together in the board and putting the lighting back together ready for our insulation resistance test. Our next circuit, the D.O.L and Motor, is fed from this subboard, but we're just going to do it directly on that circuit. When we get to our exam, you'll find that these are all fed from one board. So, using a screwdriver, take the live out of the breaker, as well as the earth from the earth bar. Now, because we are using the same linking out lead as before, we do not need to re-null our tester. Yeah. So for this procedure, go on the live, the earth, and hold it so you can see it. we're getting a reading of 0. Now that to me means that I need to re-null my leads. So whilst I do that, now that I've re-nulled my leads, I can test and see that I'm getting a reading of 0.04. Now, with the D.O.L, it's measured in 2 parts. The first part is from the distribution board to the top of the switch. We then measure from the bottom of the switch out to a plug. Now you can open up this and join it out in here. Alternatively, you can use a small piece of cable like this to link it out. Now I'm just going to re-null the tester with this linking out lead. Now that has been nulled out, I can connect it into the connector block between the live and the earth. And with the tester, test between what is the live and the outgoing earth. My reading is 0.01, which is to be expected for such a short run. Now, as you see here, we take the first half results and add it to the second half to get a grand total going from the board all the way down to the plug, which then means that my R1, R2 reading for my D.O.L is 0.05 ohms. We then do the same procedure with the R1, RN. So I have just reconnected everything back up, and then I have also re-nulled out the linking out lead. .02. Right, I'm going to skip over the last bit, but I'll rejoin you when I've completed it. So my final value was 0.02 plus 0.02, as that's what I got when I re-nulled out that little linking out lead and tested down here, which then gives me an R1 RN value of 0.04. Now we are moving on to our ring. We're going to start with our step 1 on our ring. This involves disconnecting the lives the neutrals and the CPCs from the board. Remembering you have to re-null your leads with the crocodile clips on, as we are no longer using a linking out lead. So when we're nulling out our leads and the crocodile clips again, they're all null. So let's go with live first. Crocodile one end to one end, 0.31. Live was 0.31. Little bit of a difference there. Neutral is 0.09. Now, when we are doing this, no one is fussed of the readings. We are more interested in the procedure than we are of the readings. So, end to end on the earth, 0.9. The earth was 0.09. Next, we cross connect the legs. Now, as I am going to be using linking out leads, I'm nulling out all of the leads, like so. So, we cross connect our legs, like so, with the marked brown connected to the not marked neutral, and the marked neutral connected to the not marked brown. We then test at every point. 0.4, 0.6, 0.7, 0.6, and we take the highest reading from that one. So for that was 0.06, and that was our measured result. We then connect onto the earths. Once that has been done, we make sure that we change in the plug between the earths and test at every point. There we have a high reading of 0.06. Again, measured. Once we've finished with that test, we then reconnect everything back up in the board, like so. We can then, with our sheet, work out our calculated value. So for step 2, we are taking little rl, so little r1, little rn, adding the two together and dividing by 4. This then gives us our calculated result. As we can see, it's a bit higher than what we measured, and that was probably because our L reading was substantially higher. But as long as we can see the procedure, that's all that matters. Next, we are moving over to our insulation resistance test. Now for this one, we make sure that all sensitive equipment, like the lamp, is disconnected before we start. We then set the tester to insulation resistance on 500 volts, then test between live and earth, live and neutral and earth on all circuits. So testing between live and neutral. Between live and earth. Sorry, this is live and earth, that one was neutral and earth. Remembering, when we test on the lighting, we have to operate the switches.
We've got two kinds of circuits. We've got a ring and a radial. We've also got on So if I'm on concentrating those, then I can make a free picture.
As I've sped through the process, I've tested between live and neutral, live and earth, and neutral and earth on the sockets, on the lighting, whilst operating the switches on each one. So testing between live and neutral, operate the switch, and again each time. Then testing between live and earth, again operating switches, and then between neutral and earth whilst also operating switches. I've then also tested in this distribution board down to the top of the D.O.L. Remembering the D.O.L is split into two halves. I can then test with my plug-in device here. Between live and earth, between live and neutral, between neutral and earth, and now I've verified that the entire installation has greater than 500 mega ohms on the resistance. Test at 500 volts and we'll get in greater than 500 mega ohms on all circuits. This is the end of dead testing. This is the end of dead testing. We now can prepare our board ready for live testing. We've already kept covers on everything as we're working through, as all covers need to be on for installation resistance test. Now that the board is live, we need to prove that it is live by doing live polarity. This is essentially the same as safe isolation, where we check that our unit works. We check, make sure that it does comply to GS38, and we go 230, 230, and nothing between neutral and earth. Now, if it does buzz, that could mean that it is a TNCS system and you've got continuity between the two. So we have now confirmed that this live cable is in fact the live cable. This one's neutral and this one's the earth. So we set the tester onto Z no trip, ensuring that it is on LPE. We then disconnect the main earth from the board and connect onto it. With our other two terminals, we put them on the live and neutral and press test. Now, because we are on no trip, we are trying to make sure that we do not trip the RCD that is serving this bay. As a result of it, it will take a while for the results to come through. .69, that is our ZE value. We can then reconnect the earth back in the board. And make a note of that reading. So our ZE was 0.69 ohms. Next, we move on to our PFC, where similar to ZE, but we put the earth back in, clip onto the earth bar, and what's on there? Again, we are trying not to trip the RCD, so it will take a while for the results to come through. We are making sure that the setting is on LPE, as we are now testing between the live and the earth for the amps value at the bottom for the PEFC. which is 137 amps. Now bear in mind this is wrote in amps, whereas on your test sheet it is asked for in kilo amps, KA. So we can write 100 and, I can't remember what it was, 37 amps, also known as 0.14 KA. Yeah. And then ensure that we're back in the same scenario again, where we're clipped onto the earth bar and on there, but we press the F1 button to change it from LPE to LN, and we press test. And this should be a quicker test, as it does not have to worry about the RCD. 1.87. Sorry, 187. 187 amps, also known as 0.19 KA. It is at this point now where the board cover goes back on, like so. So at this point we can then take our padlock off and turn on our RCD. And the first test that we do with the RCD is a functional test to ensure that when there is a fault it does operate, like so. Next, I turn on the circuit that I'm going to be testing, which is the sockets, and change the lead to a plug top. I then plug at the middle of the ring or the furthest point and set the tester to RCD time. We then make sure that it's on 30 milliamps on half times at 0 degrees. This should not trip the RCD, where it says it's greater than 301 milliseconds. We then go to 180 degrees, test again. This should not trip, so at 310 milliseconds. We then go over to 1 times at 0 degrees, where this should trip the RCD. So 27.3 milliseconds. We then move over to 180 degrees, and we need to remember to reset the RCD. And press test, and that one is also done. We then reset again and make a note of our results. Now for this we take our highest reading, and our highest reading for that one was 27.3 milliseconds. Next we do our ZS test. So we set our tester back onto Z no trip. We ensure we change it from LN to LPE and test at every socket, every point. Unfortunately, because the RCD is here, we have to wait a while for the result. So 1.02. Point 73, 0.98, 0.71. So then we can take our plug out, and our highest reading out of all of that was 1.02 ZS, which is in ohms. Now we can then calculate the remaining ones as well. So our lights, we can calculate that it is 2.36 plus our ZE, which is 0.69, which added together is 3.05. We can then do 0.05 plus 0.69, which gives us a dead pen 0.74 ohms, and that is our ZE for our D.O.L, ZE for our lights. That is testing complete. So now we'll look at filling out the test sheets. So details of the client. So this is whoever asked you to carry out the work, or the organisation you're carrying out the work for. So for this one, it is Nottingham College. Installation address, where did we carry out the work? So for this one, it's Highfields. Yeah. Description of installation. Now that is asking you whether it is a domestic, commercial or industrial type setting. So for this one, it is commercial. Yeah. It is a new installation. And what is covered by it? Well, what have we tested? We tested the lights. We tested the D.O.L and Motor. And the ring. Yeah. Design. Now, we didn't design it. So for that reason, it is N.A. on the signature line. Construction, once again, N.A. Inspection testing. Now, this paragraph here basically states that you have inspected to the best of your knowledge and you have done everything in accordance with BS 7671. So that is obviously the regs book. Amended to, and then whatever date we're working on. So as it is now, we are currently working to the 2022 date. However, because the rush amendment that went through last year, 2024 is also acceptable there, but do not see date and write today's date there. Next, we then sign it, date it, and then name it, because we are the inspector. We then say how long for it then to be tested. So for this one, because it is a commercial, we are saying it is 5 years. Okay. So, moving on to the next page. There is no designer. There is no constructor. However, we can fill out the inspector as we are the inspector. Now, feel free to make up a company or make up an address and put that in, or put your address in. As long as there's an address in there, that's what matters. Now, all of this information, most of it will be given to you on the day. So I believe it's TNCS system that's given to you. We know it's AC, so we must tick that AC box, and it is a 1-phase 2-wire. We know that. Nominal voltage is 230 with 50 Hertz frequency. Now, usually we'd leave these blank and we'd fill them in later on. However, because I have already done my results here, I know that I already done supply polarity. There is no other supply, so that's NA. I know that my earth fault current is the higher one, which is this one here. So it is 0.19, and my loop impedance was that one there, which is 0.69. Supply protected device. Now this refers to what is supplying the board, not the main switch at the board, what supplies it. Again, this is given to you on your exam. However, this can be found out by inquiry or investigating yourself. So, means of earthing. We haven't installed an earth electrode, but it does go back to distribution facility. Maximum demand, again, given to you. For this instance, we're just going to say 80. And we're going to say that it's a 88 1 type 2 100 amp. There was no earth rod or tape installed, so that's NA. Earth and conductor, right, so the main earth was copper and it was 16 mil. Now we confirmed continuity of that, so we can tick that. It's copper for the bonding. It was a 10 mil and we confirmed continuity of that. Notice how we are not putting in any of the results here. So these results that we got are good to have, but they don't actually enter our test sheet. Yeah. It was on to a really short water pipe and there was no other types of bonding. Right, main switch. So this is where it starts to ask of what the main switch is. So this one we were in the workshop, which was room 114. Now I always like to put the distribution board reference there. So it was DB1 that we were working at. So the main switch, it was a 61008 RCD that had 2 poles, so it's switching both the live and the neutral. The current rating on it was a 63 amp and there was no rating or setting that could be changed on there, so that is an NA. Its voltage rating was 230. All of this information can all be found out by looking at the breaker itself, looking at the RCD. It has the BS number on it. You can see what the rating is. It tells you what voltage rating is. And then all of these it also tells you. So it was a type A that we were using upstairs. It was a 30 milliamp RCD. There was no time delay on it. And the measured operating time now, when we'd done our RCD test, it was 27.3 milliseconds. So 27.3. Right, now that's that done, we're on to our tick sheet. So, condition of consumer's intake equipment. So a visual inspection of the consumer's intake equipment. Well, we've looked at it and it's there, so yes. Now for these, as you can see, you can only put a tick or an NA. So, yep, that one's a tick. Number 2, parallel or switched alternative source of supply. That is an NA because there is no other source of supply. Protective measures, automatic disconnection of supply or ADS. Well, that's a yes because there's the MCBs that all overprotect and switch off and automatically disconnect. So that's a yes. Basic protection, yes, I can't get my fingers into any enclosures, that's basic protection. Protective measures other than ADS. Now, a lot of people think that means RCDs, but that is not the case. This is referring to things like SPDs, etc. and stuff like that. So for that one is NA. Additional protection. So additional protection is RCDs. So that is a yes. Distribution equipment, yes, that was there. Were there circuits, both distribution and final? Yes. Was there current and isolation? Was there isolation and switching? Yes, I could isolate and switch off circuits if I wanted to. Current using equipment that is permanently connected. Now, the one thing on there that was connected, that's permanently connected, is the D.O.L. That has an electromagnet in it that is constantly having energy flowing through it, waiting for you to press that start button to pull it into place and keep it going. So yes, that is there. Identification notices, well, there were stickers on the board saying what circuits were, so circuit charts, diagrams, things saying danger 400 volts. Yeah, okay, yeah, that was there. Location containing bath or shower? No, there was no bath or shower. Other specialist locations, so that's referring to, I believe it's section 7 of your regs book, where it talks about swimming pools, fairgrounds, temporary installations. So there's none of that. And prosumers, low voltage electrical installations. Now, prosumer is someone who produces electricity. Yeah, so we consume oxygen, but we consume carbon dioxide. So prosume, low voltage, so solar, wind, micro hydro, no, none of that. Yeah. Comments on existing installation. Now this is referring to an addition or alteration, so that one we don't need to do anything. Lastly, this certificate is only valid when blank schedule of circuit details and test results are attached. And in brackets here, in case you get stuck, it says enter quantities of schedules attached. Now it's asking for schedule of circuit details and results. There's our circuit details, and there's our results. And it's one of each, so therefore it is just one. One schedule of circuit details and one test results attached. We then move over the page to the next one. So, schedule of circuit details. So, DB reference, we've agreed that this is DB1. Location was in workshop 114. And it was supplied from, now you can say, mains, meter, or origin. I don't know how you spell it. Origin. Fuck it. So you could say any of that. Distribution circuit overcurrent protected device. Now this information is what we wrote out up here. So it's just copy that down here. So we said it's an 88-1. It is a type 2 rated at 100 amps. SPD details, there is no SPD, so we tick NA there. We go circuit 1, 2 and 3. So number 1 was the ring. Number 2 was the lights. Number 3 was the motor / D.O.L. Now, type of wiring. This is all found at the bottom here. Now, we know that it was in non-metallic conduit and non-metallic trunking. So we can write C/E if it's in both. If it's mainly in conduit, just write C. If it's mainly in trunking, you can write E. So for this one, because the majority of it was, I believe it was all in conduit, is C. Reference method. Now this one we find out by using our on-site guide. This is method B, containment fitted directly to a wall. Yeah, which is reference method B. Number of points served. Now the ring had 4 double sockets. The lights had 1 light and 2 switches, so that is 3 points served. And the motor and D.O.L had the motor and the D.O.L, so that's 2. Next we move over to conductors, number and size of live conductors. So for the ring there was 4 at 2.5 because there was a live, 2 lives and 2 neutrals. Remembering that on this sheet the neutral conductor counts as a live conductor. So for that it was 2 times 1.5 for the lights and 2 times 2.5 for the motor. 2 times 1.5 on the sockets. 1 times 1.5 for the lights and 1 times 1.5 for the motor. Now, all of this information can be found out by looking in the board itself. Now, I know that these were 60898s. They were all type Bs. The 32 was on the socket, the lights was on a 6 and the motor was on a 16. Breaking capacity, remembering that this figure is the figure that we see on the breakers that are in that box, given on the breaker in amps. So you may see 6,000 or 10,000 on there in the box. But then it's asking for you in KA. So it was 6 KA. Our maximum permitted ZS can be found out using our on-site guide. Yeah, page 145. He says with not so much confidence, but we can find that out through there. So we know that on page 145, have a look, so the ring 1.1 lights 5.87, motor and D.O.L is 2.2. Now, RCD. We know that the BS number for the RCD is on the previous page, just there. 61008. We know that it was a type A, as I said on the previous page. It was a 30 milliamp RCD with a rating of 63 amps. We then turn over the page. DB reference was DB1, the ZDB, so the ZE for that board was 0.69. The IPF was 0.19. We done polarity. There is no phase sequence, and there was no SPD. Now, we did not do an earth electrode resistance test, so that is an NA. However, I just checked the numbers, and that was the serial number for the one that I was using. So we make sure the draw and arrow, because not only do we do it, obviously it was a multifunction test, but we've done it on all them tests. 1, 2, 3 circuits. So the ring, we do need that. The others, we do not need that. We don't need to do long lead or method 2, I believe it's called, on any of their circuits. We tested at 500 volts. We've done polarity. We pressed the test button. We didn't have an AFDD, so then I can start populating, taking the figures from here. So my little R1 was 0.31, the little RN was 0.09, and the little R2 was 0.09. The R1, R2 was measured as 0.06, and then we can write in the remarks section that R1 plus RN was 0.06. Then we can also put in here that the there we go. So we've covered here that we have calculated it as well. However, that if you do fill out your sheet like this on the day, this will get submitted as well, so that will also show that you've calculated as well. Circuit number 2, that was the lights, wasn't it? So that was 2.36, and the D.O.L we said was 0.05, and then we can write here as well, R1 plus RN, R1 plus RN equals, for the lights it was 1.37, and for the D.O.L it was 0.04 ohms. Okay, so we said that we got greater than 500. On all of that. Here, live to live, it means between live and neutral, or if we're testing three-phase, L1 and L2. Yeah. Here, live and earth means both live to earth and neutral to earth. Yeah. So we can write in there if we have neutral to earth fault, and we don't need to leave this blank on a single phase. Maximum measured. So our ZS for our sockets was 1.2. Sorry, 1.02. It was then 3.05 on the lights and 0.74 on the D.O.L. A disconnection time. So the disconnection time is that one there, 27.3. Now, because there was only one RCD, if it trips on that time on one, it'll trip on that time on all of them. Yeah. All that is left for me to do now is put my name, sign it, and date it at the bottom. And that is my test certificate complete.